Hey guys, just want to do a quick video about the results of the test so far. I think one thing that really happened is that there's a huge skew due to the wind. And just to give a background, these tests were 3 miles, so 3 laps on a 1 mile cul-de-sac or 1 mile circuit. And the problem is that the wind is buffered, so the tailwind is buffered on the way, or is kind of obstructed on the way back due to trees. But the headwind is there's no obstruction whatsoever. So you can think about it like if there's a 20 mile headwind, I'm facing the full 20 mile per mile headwind. And in terms of the tailwind, I'm not getting that full 20 miles per hour tailwind. I'm probably getting like a filtered 10 miles per hour or something like that. No, it's not as substantial. So I think that's what's really kind of skewing the data in terms of like, the ratios that we see. So for example, the control, the ratio is 86 watt hours to 68 watt hours for the 20 to 15. So that's a little over like, it's like 1.2 or something like that. But if you take the run I did today where it was really, really windy, I had 56 watt hours to 16 watt hours for the 15 mile per hour. And that's like what, a ratio of three or something like that, or four. That's a huge difference between four and like 1.2. So I think that's kind of what's happening at the moment. I mean, that's my best explanation of it for in terms of just the huge differences. Also, there could be differences in temperature, tire pressure. Uh, so so I'm not quite sure, but what I did was I did an average of all the different tests that I have so far, the ratios between 20 miles per hour and 15 miles per hour, and then I applied that to the 15 mile per hour 240 watt generator run. I hope that makes sense. So what I'm trying to do is I'm just trying to average out the variance that we see due to wind, maybe different conditions or whatnot. Um, I assume these tests are fairly accurate. I think I did a good job in recording the numbers. But anyway, what's the result is at the last row, the average, um, is the watt hours is about 36.7, which comes out to about 12 watt hours per mile. The estimated range is 82 miles, and the miles per gallon is about 100, with all with the average. So I think that's a little bit closer to what it could be. Obviously, the conditions that you face um, when you ride on the street or in your area with elevation and wind would be varied. But I think this is and of course you could face situations where there's no wind. You're on a perfectly straight road, no elevation. So this is kind of the average of that, and I think this is reasonably fair to say. But that being said, in terms of goals for the bike, I really do want it to be 20 miles per hour, 100-mile range, which even with this average at the moment, it's a little bit below that, so it's 82. So I definitely need to have that 420 watt charger to hit that level. Um, yeah, so that's about it at the moment. Yeah, I definitely need to do more tests, but unfortunately, it's going to be pretty cold in the next couple of days. So, and I'm just going to figure out. I'm going to look for that 420 watt charger as well, and just trying to finish up all these tests and to conclusively say, that the hybrid is a success, or it does it do good things, or does it have advantages from both systems, electric and gas, and does it combine it and have minimal disadvantages, or is it kind of just have kind of not that great parts from both and just huge disadvantages in terms of, for example, weight? But anyway, that's the video. Hope you guys like it. Like and subscribe if you can. Bye.